Yes. Yeah, yeah. So, am I audible? Okay. So, very good afternoon to one and all present here. So, as Dr. Bishop have mentioned that as Principal Sir is busy with some other work. So, let us start this webinar on robotics. So, first of all, I thank the organizer, the coordinator of this webinar, Dr. Bishop Debarma, the head of the department in charge of North District Tripura Polytechnic. So, I'm very thankful for this giving me chance to present to you this robotics. Basically, I have done this robotics during my master of studies, and there only I met Dr. Bishop as a colleague, means as a classmate. He was like studying the automobile engineering there, and I was the um, computer integrated manufacturing. So in that way we are known to each other. So he asked me to deliver a talk on this webinar. So first of all, I talked to him and discussed regarding the topic, like what should be the topic to be delivered. So we come up with this topic at the end, that is the robotics, its application, then future of that robotics and consequences to human society. So basically, these robots are nowadays everywhere in daily life, right? So all of you are familiar, most of you. So even this topic, why we have chosen is one more important thing is there that I want to share with you, because I was there in the during my BTech, that I have done some industrial training in the in oil in Duliajan, that is the Oil India Limited oil. So there we are means given the chance to work in the this IC engine lab or that. So there we have seen so many staff who are working on the IC, means that CNC machines or lathe machines, that basically that machines are required for drilling of the oils, crude oils. So there we have made so many junior engineers that are basically from the diploma students. So what I want to bring this topic, because in every industries or any organization, if you look into that, we see that most of the practical works that are done by the diploma students, and they are very good at if I have to say that they are very good at practical knowledge. Apart from like in BE or whatever BTech level students are there, they are mostly strong in the theoretical part. But if you are if you analyze the things, then we see that the diploma students are very good at practical knowledges. Like I used to teach some of the students in my college also, because we have a intake capacity of 10% of in the third semester from diploma right. So that was the brief introductions. So uh, I think I can start now with this introduction. So I can share the slide. So I think my slide screen is visible. Okay, so today's topic is we have Susan, that is robotics, application, future, and consequences to human society. Already the coordinator have introduced about me, and that is organized by Department of Mechanical Engineering, North Tripura District Polytechnic, Dharam Nagar, Tripura. So basically, all of us are familiar with the robotics, right? So because whenever I did my master's, I have studied the robotics as a subject, okay, and also I have taught robotics. Somebody is speaking. Yeah, thank you. Right. So since I have taken this topic, robotics, that I have studied during my master's as a subject. Okay, that is a very big subject, and also I have taught BTech students during my this 4 year students as an elective subject, that robotics. Okay, so this is a very big subject. If you want to learn all the things, then it will be like a 1 semester course, right? So here we have only 1 hour to 2 hours time to discuss these things. So I'll try to cover up all the information that will be required for understanding the robotics and what are the applications we can do with this robotics, right? So still means, even though I'm giving the lecture on robotics today, right? So basically my research area is best, if you want to know about my research area, that the coordinator have mentioned, is like, this is my research area that I have done in my PhD. That is the single point diamond turning. So single point diamond turning is basically a lathe machine that we generally study in the workshops, but that is generally the macro level. Okay, we turn the workpiece in a macro level, like millimeter or centimeter range. We remove the material and then we get the required workpiece, like nut and bolts, or like any shaft required, right? But in this single point diamond turning, we basically deal with the ultra precision. That is the nano level, not the micro level as well. We deal with the nano level. So you can see this workpiece, that is the aluminum workpiece, right? So that workpiece have turned by using this single point diamond turning. And you can see, like, in the single turn, you can see like mirror surface, that this is reflecting this image on the surface, right? So apart from that single point diamond turning, I used to do the numerical simulations of these processes, and any other numerical simulations, like a turning process, then nano indentation process, or plunge cutting. Basically it's a taper turning. So in that tool will be generally the linear motion in the increasing depth of cut, right? So generally in turning process, or this phase turning process, we have the constant depth of cut. But in case of taper turning, we generally call in the diamond process, is the increasing depth of cut. So from zero thickness to some depth, we'll be generally cutting. So basically why we do these things, because we generally machine, apart from the ductile material, we also machine the brittle material, like glass also you can machine with this process. Okay, like we have seen the contact lenses. So in contact lenses also we can machine that uh, workpiece. That contact lens can be manufactured directly from this CNC turning machine. Okay, so that all about my research work generally. Okay, so let us come to our topic, right? So I hope I am very much sure that all of you have know little bit, at least little bit, about the robotics, right? So I can show you some of the images that will give you the idea that you might have seen already, right? So here I have to mention that this robotics, or whatever we are now going to talk, is because of the development of the technology, basically. So because of the development of the technology, we are able to build so many this kind of robots, which will be helpful for our society as well as daily life. Okay. So nowadays, what happens is that because of the technology, we are very much dependent on technology, right? So what happens is that like we are now always busy with mobile phones, smartphones, then all the electrical or electronics equipments. If you don't have this in a daily life, it will be very difficult for the person to survive, right? So nowadays, like if I tell someone to stay away from the mobile phones for a day or 2 days, then it will be very difficult for him to uh, concentrate on his work, right? So in frequent time, we used to check our messages or see the WhatsApp or Facebooks, right? So this is because of the dependency of the technology, right? So because of that, also we are running towards the technology that we are now in the industries. Also, we are dependent on the automation, right? So these robots are because of the automation we are required in industries. Because like if you want to sell some product from the industry, then you have to achieve the time limit, and you have to have the in the less price, and less the quality should be good, right? So because of that, we need this kind of automation and robotics in every field nowadays. So here is the pictures that you might be familiar, right? We all watch the Hollywood movies or also Bollywood movies. So this is from the Iron Man. This is for Transformer, right? This is the Pacific Rims or like Avatar. All of you have seen these movies, right? So this is the concept. This are coming from the robotics, right? So apart from like human being, we are controlling the robots for our needs, right? Then also these are the real life robots that mostly nowadays in use application in various fields. Like this one is the from military to carry the heavy weapons to some hilly areas, right? Then these are the robots mostly used in the industries to carry out the assembly process or any kind of process that that process is required. Then these are the humanoid robots to serve the people in society, and some other extra requirements like pet dogs that are made from the robots, right? So these are extra things that human beings are now discovering one by one throughout the this development of the robotics, right? So wide range of robots you can see like in military or in the industries where most of the things are used to manufacture the product. Like in automobiles, you can see like manufacturing of the car. So all the processes are done by robots. That robots you can see here, yellow color, right? And in defense sector also, like we can use the robots to check the this mines on the with this ground, okay? Or like you can see the enemies, you can use the drones to check the enemy areas. Likewise, you can use the robots, okay? Then the robots can be like very small, as a small size as this coin, or it may be big as a home or house, right? So that is the variation of the robots you can have, okay? And also the applications wise, like you can explore the depth of the sea, okay? You can have the marine robots, or you can have the space robots where you can explore the space, okay? Other these planets, right? Like you can see it's a Mars planet, this robot you can exploring. So these are various applications you can see. Mostly robots are used in industries, okay? Then space exploration, nowadays people are that space stations are using, because sending a human being to explore the planet is very dangerous and it is very risky also. So now because of that, robots are used to explore the thing. So they can send the information, images, or some sample. They can analyze itself there inside the robot, and then they can send the information whether the water is contained in the space or that planet or not. They can give all the information, right? Then healthcare sector also nowadays that robot have means immersed, right? So like automatic surgery of the patient that can be done by robot itself, because in some cases very complicated and precise surgery will needs the robots, because in human hands can check in during the operation, right? So because of that, in some cases like precise operation or surgery, people are using these robots. And like remote operations can also be possible because of this healthcare robots. The person, that doctor may be in the some other place, and the patients will be in the some other place. In that you have the robots, so that robots can be controlled by remotely by that particular doctor to operate on that patient, right? Then, as I mentioned, these are the military robots, mostly used to carry the heavy weapons to the hilly areas, or disposal of the bombs in the mines that is be kept in the floor, means that ground. Okay. Likewise, you can use different applications of the robots in military or defense sector also. And if I have to mention the industrial robots, we have so many applications, right? So like welding, we are generally used, then painting of the components automatically, then assembling, like all the processes, that tightening of the nuts and bolts, then welding, right? And then bringing the components and placing on that particular position. All these are done by this assembly robots. Then testing, basically this also need the robots. Okay, so like after manufacturing all the components, they have to undergo the testing, so that whether it is functioning correctly or not, that we have to do by these robots, testing robots. Okay, and then packagings are also there in industries like food processing industries. Mostly robots are used to packaging. Okay, so like they have to uh, continuously count the packages, and they have to put in the box, in separate box, and they have to seal it. Okay, so all these are done automatically by the robots. Okay, so these are the list you can have, like manipulation, assembly, spray painting and coating, arc welding, spot welding. So all are have so many applications in industries. Okay, so these are endless. If you want to talk, then we can, like, it will be endless applications you can find. Okay, like, and remote applications like include the undersea exploration. In undersea, what are the means what are the depth is there, whether means like if some ships are drowned inside the sea, then by using the robots they can search for the survivals also, right? Likewise, you can do this remote applications. Then these are some other advanced applications of the robots, right? Nowadays people are using for their easiness of the life, right? So most of the people are using this kind of robots to clean the floor, right? Instead of having the some kind of labor. Okay. Then you have this cooking robots also. They can just you have to put the menu, then the robots will cook for you, right? Delicious food. Then you have the waiters in the restaurants. Nowadays in India also you can find in some restaurants that robots are serving as a waiter, right? Then this is the latest robot that you might have seen in the YouTube channels, right? That is called the Sophia. So this robots is the ultimate nowadays. You can say ultimate robots. They have the artificial intelligence included on the robot. Okay, so they have the sensors like a human being. They can get the information, visual information from the surrounding, like they can identify the person. Okay, then they can have the conversation with the some person. If you are asking the some question, then they can reply based on the artificial intelligence that is stored inside this processor, okay, inside the head, right? So that is the latest technology that humanoid robots you can have, right? So this is the development stage of the robots, right? So this is the industrial robots in operation worldwide. Okay, so that is the all data, basically 2017 to 2020, right? So that is the forecast, basically how these robots can be used in industries. Okay, so that has been predicted that around 3.3 millions of robots can be will be in place in the industries by 2020. Okay, so worldwide, that much 3 million of robots may be used in the industries where automations are required, right? So that is the scenario of industries in worldwide. Okay, so year by year the amount of application of the robots in industries are increasing, right? So here this 12% has increased. Likewise, at by 2020, the application of the robots has been increased to 14%, okay, per year. So all of now I have told to you is like what is the robots and what is the different applications, right? So that may be the question, like what is the robot now? Okay. So it is an electromechanical device with multiple degree of freedoms that is programmable to accomplish a variety of tasks. Okay. So we have seen some of the machines, right? That you may have done some turning operation by lathe machine, or you might be using that washing machine, right? So these are some kind of machines. Okay, so they are also perform the work that you are assigning to the machine, right? So you're asking the washing machine, or you're setting the washing machine to wash the clothes, right? So that can be also a robot. Okay, so what you can say that about the robot is that it is a combination of many machines that will be reprogrammable, and it can perform multitasking. Okay, that is the you can say the basic difference between machine and robot. Okay, so both are almost same if you are looking into the working of that robot and machine, right? So in robot also you're assigning some task and the robot will perform that task. Okay, so that is the thing. In machine also, like in washing machine or lathe machine, or you can say that higher version of the lathe machine is CNC machine. So in CNC machine we are giving some code, okay, CNC code, and the CNC machine will perform the turning operation whatever you have given, and it will give you the required geometry, right? But in case of what is the difference in robot is that that can be reprogrammable, and it can perform the different operations. Okay, not only the turning operation in case of lathe machine, or in case of what you can say that washing machine, they can only wash the clothes, right? But in robots they can uh, perform multitasking. Okay, so that is the basic difference between robots and the machine. Okay, so you can have the multiple degree of freedoms also. That is the thing about the robots. Okay, they have multiple degree of freedoms, means they can move their that tool or the end effector to different direction, okay, to get the work done, right? So we'll see what is mean by this multi degree of freedoms. Okay, so that will be it will be in the coming slides. You can find this what is mean by degree of freedoms of the robots. Okay, and then how you can perform the different tasks. So these are some of the basic definitions of the robots, right? So that is given by our Robotics Institute of America, then ISO, that they have defined the robots. Okay, so in basic words, that robots can perform the multitask. Okay, and they can be reprogrammable. They can be programmed to perform different tasks. Okay, and these are some of the definitions that is to be discussed. If you are like if you're taking the class of robotics, then this will be helpful for you. Okay, so I think there is this is the webinar, so I think that this is not will be required right now, right? So all these things has to be understood when you are means researching or trying to make some kind of robots. So this definitions or terms has to be known to you. Okay, so right now, since we are having the discussion of robotics and their wide applications and then futuristic of the robotics, okay, so I think we can skip this one. Okay, then we have to specify the robots. Suppose we are trying to build the robots, or we are trying to purchase the robots to for some of our work. Okay, then we should know what are the specification that we have to specify to the manufacturer, or when you're trying to build the robots, then what are the specification that you have to consider for making the robots. Okay, so that we have like major axis, minor axis, redundant, reaching the around, obstacles, avoiding the undesirable configuration. Okay, So these are the things you have to take into consideration. So if you have a object here, then whether the this robot can reach this object or not, or if you have a position, like suppose you have a workpiece here, okay, then you have to sense the position. Suppose you have this one, you have an object here, and you have to pick this object, and you have to displace the object to somewhere else, okay, like pick and place robots. Then you have to check this major axis, minor axis, then redundant, like reaching around the obstacles. Suppose you have some kind of obstacle here, barrier, that barrier, whether it can reach this particular object or not. All this criteria you have to check, okay. Then payload means what is the load carrying capacity of this robot, whether if have to carry this object or not, okay. Like if you have a very heavy load and the arms are not correctly designed to lift this object, then it will be not useful, right? So depending on the object that you are trying to lift, you have to choose the capacity of the robot, okay. Then repeatability is very much important in case of robots, because robots are replacing the human being or human operator because of this repeatability only, because in industries most of the works are repetitive, okay. So human beings or human laborers are very much what you can say, if you are asked to do the repetitive work, people that human operator make become boring, okay, to perform that repetitive work. They have to be like different type of operations should be there, otherwise the people will be bored, okay, that to perform the same operation one again and again. So because of that, the robots are replacing the human labor, right? So that repeatability has to be there, to repeat the process again and again, okay, number of times. Then precision and accuracy is the most important in case of any kind of machine or robots, okay. Because of the precision and accuracy, you can place the, or you can hold the object and place the object in the required position, okay. If the objects are placed in other position, because of the less precision and less accuracy, that may be that may affect the operation. Like suppose you are assembling the car, okay. So in assembling the car, if you have placed the window in some other place, because of the less precision and accuracy, the glass may not fit on the position, and that may be the defect of the car, right? So that precision and accuracy should be there in the robot, okay. So apart from that, you have this speed, okay. Speed also one criteria that has to be there in the robots, okay, how fast they can perform the task, okay. So because the speed also defines the manufacturing time, okay, so that is called the lead time of the product, okay. So the objective of the industry is to complete the task in a less time so that it can catch the market, okay. So that speed also defines the specification of the robot, all right. So these are the motivation why we need to go for robots. In some cases it may be dangerous, like space exploration as I mentioned, then chemical spill cleanup process in the industries where very dangerous chemicals are produced for drug preparation or any other what you can say, that food products. In that also we use some kind of chemicals. So if that chemicals are hazardous to the human operator, then you have to replace that operator with the robots. Then disarming or disposal of the bombs in the mines, okay, that will be the defense area where you have to use the kind of robots. Then disaster cleanup, there also you can use some kind of robots. Then boring and repetitive work that I have mentioned in welding car frames, part pick and place, that is in case of food processing industries, you have to pick and place the objects like packages, you have to put in the box and then you have to seal the package, right? So all these processes are repetitive and boring, right? So human operator find boring for this repetitive work. So because of that, some mistakes may happen in the process. So because of which we generally use the robots. Okay. Then, as I mentioned, high precision and high speed work. In some cases, human operators may not be useful. Okay, like surgery, as I mentioned, or precision machining, we don't use, cannot use the human operators, right? So, like if I have to take about the CNC machines, so CNC machines, ultra precision machines, or like uh, lapping machine or honing process, in that these are the very precise operations, right? So in that case, if your human operators are performing manually the process, then there may be that precise precision you require, like surface finish and the surface tolerances you require, that may not be achieved. Okay, so this term robot has been derived from this robota, that is the work which is given by Slavic language. So basically, these robots come from that artificial human-like creature built for being inexpensive workers in the theater's play. Okay, that word has been given by this play. Okay, that was some theater play was there. In that, to mean this work, okay, robota was given in the year of 1920 by Karel Sepak. So this is the first robot that is manufactured by Unimation. Okay, this is the first industrial robot. Then there is the evolution, long way. We have seen some of the robots, that evolution. Okay, recently, right? So these are the robots in the like medical, then space and industries, right? And some of the evolution of the robots you can see. So these are the 1973, 1974 or 1979 industrial robots. Then you have these humanoid robots. Later on, 1984, then 1995, we have these industrial robots for welding processes of automobile sector. Then 2002, we have seen this Spirit rover for Mars exploration. Okay, it does Mars planet. And these are some of the laws that basically we generally taught teach in the class. Okay, that we have to know, right? So whenever you're designing the robots or you're making the robots, this terms has to be satisfied. Okay, otherwise the your robots will not be accepted for the application. Okay, so first is and foremost of this laws of robots is that it should not harm the human being. Okay, that is the meaning of these laws. So whatever robots you design or you manufacture, okay, that robot do not or should not harm the humanity. Okay, even and also in the second thing, that whatever the instruction is given by the operator, he should that robot should accomplish. Okay, so first thing is that the robot should not harm the human being, but in the second case, it should uh, accomplish the task which is given by the operator. Okay, but in that task, if the operator has given to harm some kind of human being, then that is the uh, violating the first term. Okay, that it should not harm the human being. So even though the operator have given the instruction to harm some person or some human being, this should not violate the first term, that it should not harm the human being. Okay, so that has to be taken care when you are designing the robots. Okay, then these things are to be known whenever, like if you are discussing the robots, then these things comes into like have to be discussed, because how the robots are functioning the task that have this kind of components. Okay, so basically you can resemble this robot as a human soldier arm, okay, or human hand. So this is basically the waist. Okay, and you have the soldiers, then arm, then this is the wrist. Okay, so Likewise, you have the base. Okay, so this will be the base. Here you have, this will be fixed in some cases, and in some cases, if you have to perform some other task like by moving the robots, then you have some kind of wheels here to move the robots from one place to another place. But basically it will be fixed. Okay, in the assembly of in automobile sector, like in assembly or like painting operations, these robots will be fixed. Okay, and they can move these joints. So I think you have studied some of the things in the machines and mechanisms about the linkages and arms and joints, right? So all these mechanisms will come into picture about the working of the robot. Okay, so am I audible, still connected? Yeah. So this is the base we have in the robot. Okay, so in that base we can rotate in this way along the this vertical axis. The robot can rotate. So you have the rotating motors will be there, our controller that will rotate the base in this axis. Then you have another motor here that will control the rotation of this soldier. Basically this will be a soldier. You have, this is the soldier and this is the part of the arm. Okay, so this will, the soldier will rotate. Then you have the elbow here. It is also one controller that will rotate the in this way, clockwise or anti-clockwise depending on the requirement. Then this is the wrist where you have the, it can rotate. So in the wrist, whatever we have the human arm, that also have the similar degree of freedom. Okay, or the rotational motion that can perform. Okay, so these motions are given the name as pitch and yaw and roll. Okay, so we'll see this one, how we can find out this kind of degree of freedoms or the motion. Okay, then this is the part is we call an effector. Okay, so this is the part where we fix the tool, whatever the task the robot has to perform. If it is suppose like welding operation, then we'll fix the welding tools here. Then if it is a painting robot, then we'll fix the painting tools or painting device here. Likewise, we can fix any number of tools that we require to perform the definite task. Okay, so because of that, there is the difference. We can differentiate between the machine and robot. Okay, so robot can perform, the single machine or single robot can perform different tasks like welding, then painting, then pick and place also can be, if you put some kind of gripper, okay, then it can work as a pick and place or human arm, right? So this is the picture that you can find out the resemblance of the robot with the human arm or human hand, right? So this is the base and you have the waist. So waist can rotate in its axis, that whatever the degree of freedom is there. Basically the robots have the 360-degree rotation, or in some cases it may be like restricted to 270 or 180-degree rotation depending on the application. But human can rotate up to like 90-degree or around 160-degree around, they can rotate their waist. Okay, likewise it can rotate this soldier to from here to here, that is almost 180-degree they can rotate. Likewise here also it can rotate to around not almost than 180-degree, but you can say that less than 180-degree, right? This elbow can be rotated. Then here also you have different degree of freedoms or different motions you can give, and this is basically the an effector, that is the arm. So here it is, you can find the gripper or any kind of tool. Okay, so based on the applications you can classify the robots like Cartesian coordinate, cylindrical coordinate, polar coordinates, jointed arm configuration. Then depending on the drive systems you have, you can differentiate between the pneumatic or power source. Okay, that is the driving source of the robots. So mostly we use this hydraulics and pneumatics for the easy application. Then electrical also can be used, but they have different advantages and disadvantages because of the accuracy that you required and the power you required. Okay, so hydraulic robots are having more power compared to the electrical machines, but the accuracy of the hydraulic machines is less compared to the electrical robots. Then depending on the work that robot can perform, like limited sequence robot, point-to-point control, like drilling operations are the point-to-point. I can give the example. Okay, so the robot can perform point-to-point. Okay, it cannot be continuous. It cannot perform the continuous operation. Like if you have to perform the welding operation, then the point-to-point control cannot be work on the welding, because welding should be in the continuous manner. Okay, but in case of spot welding, it can perform. You can use the point-to-point control robots. Okay, so these are some of the illustration of the Cartesian robots, where you can find the three linear motions of the robot arms. Okay, so it can move up and down. Then this can be in the y-axis, you can say three mutually perpendicular axis if you have. Then they can move in the linear motion only, they cannot rotate. So rotational degree of freedom is restricted here. In case of cylindrical robots, one rotational motion is there and other are linear motion. Okay, similarly you have the spherical. In that spherical we have two rotational degree of freedom and one is linear. So side by side you can find the actual robots that this kind of robots have this kind of degree of freedom. So in SCARA robots you have the three rotational motion, and this is the arm that we can give some kind of linear motion. So basically in SCARA robots generally have three rotational degree of freedom. Okay, then we find the articulated robots, mostly that is known as the fixed robot. Okay, in other words you can say that it is a fixed robot. So the base is fixed, in some places it will be fixed, and they can move the arms in a surrounding area. Okay, so the area in which this end part can move, that is called the work envelope. Okay, so in that given volume or volume region, okay, you can say the region, in that region only the robot can perform the task. Okay, apart from that it cannot perform outside this region, because the reaching this end point of the robot cannot reach to that point where it is coming outside this region. Okay, so that is called the articulated robot. In some cases we have the mobile robots, so they have the wheels, they can move here and there. So you can see this is the vacuum cleaner robots that will mostly use to clean the floor. So they can move around all the area of the room. Okay, all the regions of the room. So that room itself is the working region of that particular robot. Okay, so apart from this classification, we can classify also based on the degree of freedom. Okay, so this is only one degree of freedom. Then 2 degree of freedoms we can have to that n effector, right? 3 degree of freedom. Then we have this 2 degree of freedom, pitch your wrist. Okay, so it can rotate at this axis and this axis. Okay, then apart from this they cannot rotate anywhere. So because of that it is 2 degree of freedom. Then 3 degree of freedom can also be here. Then also, like depending on the type of robots, you can have up to 6 degree of freedoms also. Okay, or more than that. Okay, so minimum is 1 degree of freedom. Then you can have multiple number of degree of freedoms. So you can see here this robot, particular robots, right? So this is the waist, that is the base. Basically in that base it can rotate. So this is first degree of freedom. Then this is the shoulder basically, so it can rotate at this joint. So this is the teeth pendant. Basically the operator can control this teeth pendant to move the motor or give instruction to the motor that is situated at this joint. Okay, so if you have to move the robots from one position to another position, then you can put this kind of arrangement. Okay, So basically you can find the 3 degrees of freedoms. One is the waist, shoulder, then elbow, and from that wrist you can have more 3 degrees of freedoms. Okay, so that 3 degrees of freedoms we will discuss later on. So this one is the wrist, so you can have the yaw, then pitch and roll. Okay, so that basically resembles the human arm, right? So likewise you have the yaw, then pitch, then roll. Okay, so we'll see here how we can have this kind of movement. So this one is the arm of the robot. Here an effector you can see, right? So these things are already explained. So here it is the pitch we have, right? So yaw is that you're moving the arm from one position in the left, right into left. Okay, so that is called the yaw, and pitch is nothing but this one. Okay, so up and down you're moving the arm, that is pitch, and roll means you can rotate some degree, that is rolling of the arm. Okay, so likewise you can have the 3 degrees of freedom on the wrist of the human arm. Okay, so total altogether you can have 6 degrees of freedom. And if you move the robot in this kind of railing, then you can have another degree of freedom, that is 7 degrees of freedom. Okay, now if you fix the tool, okay, so if you fix the tool, that is the drilling tool, and that drilling tool also can rotate, okay, then you have added another degree of freedom. Okay, so that will add one more degree of freedom to the robot. Likewise it can add or reduce the degree of freedom depending on your requirement. Okay, so in previous slide I have mentioned about the work envelope or the working region of the robot. Okay, so working region means since the robots or articulated robots are fixed at their base, right? So this is the basically the base of the robot, so they cannot move from one position to another position. Only the end effector can move because of the connecting mechanism that you might have studied in the machines and mechanism, that if you have studied. Okay, so you have this linkage mechanism and joint mechanism, right? So because of the movements, the joints, because of the rotation of these joints, this link will rotate. Okay, but depending on that, there will be relative motion of other arms. Okay, likewise it can move to this region. Okay, whatever you can see the white spot, in that region only the end effector can move. Okay, so depending on the degree of freedom or degree of rotation they can perform at their joints. Okay, so this white region is the region where the robot can perform their work. Okay, so suppose if you place an object here, then this is the out of the boundary region of this work envelope, so robot cannot reach this object and they cannot perform the given task for this particular job. But if you place the job here or here, they can perform the required task in that region. Okay, so this is the top view of the robot and this is the side view. So in that side view, this is the region the robot can perform. Okay, so there is a rotational restriction is there for this joint. Okay, so it can rotate from this position to this position only. So you can find something like more than 120 or 130 degree rotational motion to this joint. Okay, so if you join this together, this is the top view and this is the side view, so you will get some kind of volume. Okay, so that volume will represent the working region of that particular robot. Okay, so now this end effector also useful for the robots, because in end effector only we attach the tool. Okay, whatever the required task has to be performed, that can be attached to the end effector and then the robot can perform that particular task. Okay, so these are the different kinds of gripper. So basically in case of pick and place robots, okay, pick and place robots, we have different kinds of this kind of gripper. Okay, so they can grip the object and they can move the object from one place to another place. Then they can place these objects. Okay, so suppose you have the two conveyor system. Okay, so one object is coming from this side and then you have to change the direction, and that will go to some other machine to process. Okay, then you can place some kind of robot here. Okay, and some part of the object or defected object has to be transferred to same direction. And or like you can take the example, like the objects are coming, okay, and there is some testing machines or testing robots are placed here. So these components are coming. Okay, so the testing machine will or testing robot will test the object, and if there is a defect, then the robot has to pick this defected object, and this they have to put this defected object to this conveyor to send it back to further processing. And whatever the good objects are there, they will continue to move in this direction. Okay, so in that way you can use this kind of gripper to pick the object which are defects are found on this object. They will grip the object and then they will transfer the object to other conveyor for further processing, right? So likewise you can have different kind of gripper, and this, like suppose mostly for handling the glass objects like windshield of the cars and automobiles, we usually use the vacuum suck. Okay, so that pneumatic pressure will be used in the pipes. Okay, and this will be the vacuum, so that will be placed on a glass and the vacuum will be created to hold the glass, and they will move the arm to put the glass on the car. Okay, while this carrying out the assembly operation. Okay, so you can have the fingerless gripper also, that will some kind of sticky materials that you can have, or some kind of changing geometry. Okay, so because of the geometry of this end part, they can hold the glass or some kind of objects, or some kind of magnetism can also be used. Apart from using some kind of gripper or hand fingers like gripper, you can have the magnetism also. So whenever you have to hold the object, then or the metallic parts, then the magnetism will be created, then it will attract the metal. Then whenever you have to drop the object, then the magnetism can be disconnected. Okay, the electric current can be disconnected, then the magnetism will go, and then you can drop the object. Okay, so this is the tools that you can attach to the end effector of the robots to perform different tasks. Okay, so this is the end effector where you can fix the tool. Okay, so you can fix the tools, like this is a drilling operation, or it can be the grinding operation or sanding operation for finishing the part. Then you have this NASA cutter scoop, so that will be used in case of like space exploration, exploring robots, where like you have to get the sample from the planet. Okay, the surface of that planet, like some soil samples, they can test there whether the water content or some kind of chemicals are present or not. They can use this kind of cutter on the arm of the robot. Okay, then this is the robot measuring system. They can have the some kind of measuring instruments will be attached to this robotic arms. Okay, then they can perform the testing operation. Then these are the laser beam tools, like laser cutting or laser welding, okay, or laser markings. All this can be performed by this tool. Okay, so this will be fixed on the end effector of the robot. Okay, then these are the welding tools that can be attached to this end effector. Likewise, like painting, spray painting, also spray painter can be attached to this robot arm or end effector here, right? So all these are the end effectors that can be changed to same robot, and you can perform the number of tasks. Okay, so this may be the same robot, and then you can change the end effector. Like it can be the gripper, it can be the grinding, drilling, or like this laser beam, welding tools, or spray painting. on the same robot, and you can give some kind of coding or programming you can do, and then you can give input to that programming to perform that task. Okay, so in case of drilling, the programming may be different. For in case of painting, the programming may be different. That robot have the capability that it can be reprogrammable. Okay, so these are the drive systems, basically the power that robot gets, okay, to operate the task. Is we have like hydraulic systems, then pneumatics drives or electric drives. Okay, apart from that we can have some other drive also, like this artificial muscles that is mostly used by air pressure. Okay, then piezoelectric materials can also be used. So piezoelectric materials, so if you pass the electric current, then the piezoelectric materials will give the power, like it will deflect. Okay, so piezoelectric materials are something which changes its geometry. If you give some kind of electrical energy to this material, it will change its geometry, and in opposite way, if you change the geometry of the material, then it generates the electricity. Okay, so that is the property of piezoelectric materials. Then apart from that, electrical energy, that will maybe DC voltage or AC voltage, then that will control the servo motors. That will be like DC servo motors or AC servo motors. Okay, that will be in the controller part. Okay, so to drive the motors, we need this kind of what do you have, electric motors. So if you are using the servo motors, then you should have the electric motors, and to run the electric motors you should use the electric energy. Then if you have a hydraulic cylinders or pneumatic cylinders, then that energy will come from the compressed liquid or compressed fluid or compressed air. Okay, so in that way you can move the different arms, okay, to rotate the joints. Then what we have to know about the robot is that how you can control the robots to perform your task. Okay, so suppose you want to use the robots to perform some kind of drilling operation or painting operation or some definite task. Okay, like sweeping of the floor by using the broom or different operations. So same robots can be used to perform the as a sweeper. Okay, so to you'll give the N effector, we have the gripping machine or gripping arm, and the broom will be gripped by the arm, and then you can give the programming. You can program so that the robot can broom or sweep the or clean the floor. Okay, so likewise we have different programming systems or programming languages also we have different, and the methods also different. Okay, so you can use different programming languages like Python will be there, C++, then you have different softwares. Okay, that may be the freely available open source softwares are also available nowadays. Okay, or like robot specific softwares are also available. Like if you have to if you are purchasing some kind of robots, they will provide this that particular software to program the robot. Okay, so they will have the user graphics interface. Okay, so in the computer or in case of you will be having some display devices, in that display devices you can program. Okay, you can write the code, and then if you give this code to the robots will perform the given task. Okay, so this is the three methods we have: lead through programming, teach programming, and offline programming. So lead through programming is the human operator physically grabs the N effector and show the robot exactly what motion to make for the task. Okay, while the computer memorizes the motion, memorizing the joint position sorry, then lengths and the angles to be played back during the task execution. Okay, so what it means is that lead through programming, suppose you have this robot. Okay, so just I'm drawing roughly. So you have this N effector, these joints will be there. So the person will hold this end point. Okay, so suppose you have to weld this component, two components. Okay, so now the person or the operator will move this n effector and bring this to this point. Okay, so while you are moving this point to this position, there will, because of the relative motion of the joint, these arms or linkages, the rotation will also be there. So this joints controller points, okay, these controller points are connected to the computer. Okay, this is connected to the computer. So when you are moving this end point of the robot to bring this point to here, this position, there will be relative motion of these joints. So you will be having the sensors, okay, or encoders, which will get the information how much distance it has moved. Okay, suppose it has moved something like this. Okay, then it will come this position. So this is just rough drawing. So this point has moved to here, this point has moved here, and then this point has moved somewhere here, right? So all this information will be given, means what you can say, that sensor will get the information. Okay, that movement, basically the position will sense, and whatever the rotation it has taken place, all this information will be acquired by these sensors, and that sensor will send the signal to the computer. So the computer have the software, so the software will store the information. So to move this point to this point, what are the motions or displacements has been taken by these points, okay, these joints. Now when you run the software, okay, the software will recall all this information and it will instruct these joints to move from this position to this position, right? Likewise, that will repeat the process. So once you move the point from here to here, right, and then you have performed the welding operation, then you have to move this point to here, right? So that there will be some relative motion again, so that will be stored again in the computer. So now when you run the software, okay, that process in the computer, then all this information will be playbacked, okay, by the computer, and robot will perform same way. From this position to this position it will come, then they will perform the welding operation, then from this position it will move to this position. So whatever the operator has given the movement to this robot, that computer will store and it will play back the same process. Okay, so that is the lead through. Then in case of teach programming, what will happen? The movement of the robot to required task position by a teach pendant. Okay, so you might have seen this one. I have shown in this picture, degree of freedom, right? So this is the teach pendant or teach programming. So you have the connections. It may be the wireless or it may be the wired. So wire will be there. So each controller or the motors have this connection. So switches will be there, like regulators will be there. So the operator can rotate this one to move each and every joints and the linkages to get the particular position. Okay. So if you have to move this point to here, right? So it will give the instruction to rotate this motor. Okay, so they have different separate controller or regulators or joysticks mostly used. So joysticks will be there, so they can move these joysticks to rotate from one position to another position, right? So likewise, you can teach the robots, and in that way the programming will be stored in the teach pendant, and when you run these motions, then it will repeat the process. Okay, so you can see here, this is the teach pendant. So that graphical diagram also be there. Okay, so this will indicate which button is for which joint. Okay, so you can move each and every button, okay, up and down, or increasing and decreasing button will be there. So if you press that, that joints will rotate. Okay, particular joints will rotate, and in that way you can move that N effector from one position to another position. Then offline programming, that is like you have the software in the computer, so you can make the programming in the computer itself. Then you can take this program in a pen drive, and you can put that program, you can put the pen drive in this pendant or controller, that whatever you have, or directly to the robot. So basically the robot doesn't have this controlling device. Okay, so they comes with only with controller. Okay, that robots will this motors will be there, or hydraulic systems. If you have the hydraulic motor, then hydraulic drives will also be there, only be there. The controlling or processing device will be separately be there. So you have to put the pen drive in this device, and you have to run the code. Okay, so in that way you have this offline programming. So you are not directly programming the code, okay, or the task. So you are separately programming the code in the computer, and you're transferring the code to robot through this controller. Okay, then in that way it will be called as a offline programming. Then robots may be autonomous. So for autonomous, you should have some kind of sensor and some kind of artificial intelligence or feedback system. Okay, so feedback system means the information will be acquired by the sensor. So you should have lots of sensors that will give that will get the information of the surrounding. Okay, like suppose you have this robot. I'm just trying in a rough way. Right, so there is no programming. Okay, manual programming is not there. So the robot has to be performed autonomously. That means the robot has to pick up the object. So first you have to identify the object, and they have to grip the object, and they have to place the object up in some other place, right? So it should have some kind of vision system, right? Camera or something like that, or some sensor that will detect the object, whether the object is there or not. Okay, so some kind of sensor has to be there. So first the sensor will detect the object. If it is there, then it will move the arm to get the information of the object. Okay, so some tactile sensor will be there that will get the information over there, the object has been gripped or not. Okay, that tactile sensor will get the touch sensitivity. Okay, so the tactile sensor will get the information of whether the object has been gripped or not. Then the force sensors will grip the object in required force, whether that because so that it doesn't slip. Okay, so force sensor will get the information how much with which force the object has to be grabbed. Then it will move the object to other place, and it will drop, right? So some kind of sensor has to be there to take the decision autonomously or independently. Okay, so it should have the computer or processing system to take the decision or process the information from the sensor, and to give the instruction directly from the computer to the controller. Okay, likewise you can control the operation. So that is the autonomous. In case of teleoperations is human directed motions by a joystick. Okay, so as you can see here, this is the joysticks will be there, some kind of joysticks you have, or some kind of button. Okay, so by these buttons you can control the robots. So that motion will be called as a teleoperation. And lastly, the robotics, that is basically the combination of autonomous and teleoperation. Okay, so the robots can also be take the decisions autonomously, or if you have to give some more instruction to the robots, like precisely, or some kind of like random decisions has to be made. Okay, like so many obstacles are coming, right? So the robots is picking and placing the object by its decision. The computer is taking the decision, but some obstacles is suddenly come, and they have to be given some instruction to avoid the obstacles, then the teleoperation can be added to this telerobotics. So simultaneously, this functioning of the robots will work. Okay, so these are some of the names. Just I have browsed in the net to get the idea. These are some of the softwares that you can use. Okay, these are the sites where like free version also there, freeware, or some kind of purchased softwares are available that you can try. They have the user graphics interface, then you can program it to see the operation of the robots. Okay, so they have different kind of robots, right? And then you can give some kind of coding or some kind of programming there itself in the software. Okay, then you can see the visualization how the robot performs the work. Okay, so just for your information, I have just listed this now, some of the sites. Okay, more softwares will also be available, and that is also like robot to robot, like the manufacturer provides their own software, right? So just I am to show you the animations of how the robots can be controlled, right? So this is this computer, this is the computer, and this person or operator is holding the end effector of the robot. Okay, so now he is visualizing the robots here also, means like there's some kind of software is available which can visualize the movement of the robots. Okay, so he is moving the end effector from one position to another position, and simultaneously the computer is storing the information. Okay, so this is like Air Force base, Patterson Air Force base. Some testings is there like about the robots. Okay, so they're designing or manufacturing some kind of robots and they're testing it. Okay, so this is the pendant. So the operator is stitching the robot. So the robot has to perform the welding operation at the corners of this plate or the workpiece. Okay, so he first moving the object. Okay, like here he's moving the end effector by pressing the buttons or joysticks to moving there and performing the welding operation. So basically he's teaching the robot, okay, to perform the particular task, and all this information is stored now in the robot. Now it can perform the required task, so it can keep on continuing the same process, right? So this is the teaching of the robots. Okay, so it is basically called the teach programming. Then here it's the lead through programming, right? So the operator is moving the robot's arms from one position to another position. Now robot has stored this information and it is repeating the same task. Okay, so whatever the movement is there in the robotic arm or the parts of the robot, that is recorded by the computer continuously. Okay, so that recordings is again playbacked, and if you playback the motion, then it will perform the same task, right? Then thirdly, we have this learning from demonstration. Okay, so learning from demonstration, you require a image processing system. So the robot, whatever you can see the image or the video, that is the robot's camera. Okay, so robot is seeing the person which is operating the or demonstrating the task. Okay, so the robot vision is showing now in this picture. Okay, so robot is now seeing the person performing the task. So now the robot is getting the information and it is learning. Okay, so what are the tasks the person has performed, that will be stored in the robot's memory, and it will try to mimic the same process. So in that way the robot will learn the things and it will repeat the process. Okay, so for that you need to have a very good image processing. So they should have the information about these objects. So suppose the person has performed the task. Okay, it has grabbed the objects one by one. Now when you are asked the robot to perform the same task and you have sensed the object, okay, some other object has been placed here, then the robot has to have this information that the object has been sensed. Okay, so that image processing should be there, right? So he should be it should be able to identify the object first, and then it will perform the task, right? So to have completely perform the task smoothly and accurately, you should have a good sensor. Okay, so the sensor is the you can say the backbone of the robots, because without this information, whatever you are getting from the robots, the controller will get the information, and the controller can decide the task. Okay, so that processing unit will get the information from the sensor, and the processing unit will send the information to the controller. Okay, so if the information is not correctly going to the processor or processing unit, the functioning of the robots will be useless, or there will be some mismatch of the task. Okay, so you should have the good sensor to have the good information processing. Okay, so robot sensor is something like we have sensory organs in the human, right? So all the information whatever we get from the surrounding, that will be sent to the processing unit, and the processing unit will get the information and it will send the signal to the controller. Okay, like suppose we are touching the whole body, okay, by our hand, so the skin will have the sensor. Okay, so that sensor will get the information that you have touched the whole body, so you should move the arm from that whole body, right? So the whole body, the skin, the sensor from the skin will send the information, and that sensor will send the signal through our nerves to the brain. Okay, so the brain will process the thing. Okay, so brain will get the information that the hand is on the whole body, so if you don't replace or don't move the arm, it will burn the arm, right? So the brain will take the decision that the arm has to be moved from that place. So the brain will send a signal to the sensory organs, or the means that nerves, basically the nerves. So the nerves will get the information from the brain, so the nerve will move the arm from one place to another place. So the elbow, whatever you have, elbow and arm joints will be there. The that nerve system will get excited, and it will give some kind of force to move the arm from that place. Same thing will be here. So the reference command will be there, then sensor will be there. That sensor will get the information, like visionary system will be there, some force sensor, tactile sensor. Okay, all kind of sensors will be there that will give the information of the surrounding. Then you have this reference commands also there, that is set on the robot, okay, on the processing unit, right? So whenever you get the information from the sensor, right, so that sensor will get the information and it will send the signal to the processing unit. So the processing unit will check the signal from the sensor and the reference command. Okay, if there is a mismatch of the signal, then it will get the information from that comparing unit. Then the system will take the decision and it will send the signal to the controller. Okay, so the controller will control the movements of the robot and it will perform the task. And in that way, again, the sensor will get the information whether the task has been performed correctly or not. And then the process will be continue. That feedback control will be continue. Right. So these are some of the sensors you can use for different applications depending on your requirement. Okay. So these are not to be discussed right now because I think I have taken 1.5 hours already, almost. Then just to give the idea about the application of the robots, I'm just taking the example of this application of robots in agriculture, right? So basically in agriculture also application of the robots is now very much used. Okay, so because the production whatever we are getting from the cultivation of the rice or any other kind of crops, okay, that is not sufficient to run the family or some kind of livelihood, right? So using of the robots to make the production more, that is now in the aim of the farmers also, right? So because of that, in many fields or in case of like food industries also, they are using some kind of robots to increase the production. Okay, so you can see this kind of applications like robots in automated harvesting system with control, then autonomous system for navigation of the fields, then mowing, then pruning, seeding, and spraying of the and thinning nurseries. Okay, so lots of applications are there in agricultural field also. So just I'm here to give you the just application. Okay, one area. So in other area, lots of applications are also there like medical, then military, likewise industries. If you have to talk, then it will be very long discussion. So just to give you the idea how these robots are helping the agricultural field. Okay, so basically if you consider the traditional cultivation of the rice, right? So you can have the like land preparation of the plowing by using the cows and like buffaloes, then seed sowing and raising the nursery, transplantation, irrigation, weeding, then pest and disease management, then booting and flowering, then harvesting lastly. Okay, then separation of the crops from that plant, that also one kind of process, right? So basically you can see here the time period from October to March, like the process takes. Okay, in generally in Assam or in the northeast India, we generally now this is the time like people are starting for cultivation of the rice. Okay, because the rainy season is started, so we'll start plowing of the field and then we'll start seeding of that, right? Then from 5 to 6 months will that crops that rice will be ready to harvest, right? But because of the development of the technology throughout the year, people are cultivating the rice, right? We can see in some other areas people are cultivating the rice throughout the year, right? So these are the images you might have be familiar, right? In the villages area, people are putting the water for plowing that will make the soil very smooth, or sorry, uh, for easy for the plowing. Okay, then it will be field preparation. Then this is the seeding, right? Then transplantation will take place. Then that be planted, right? Then this is the pesticides will be sprayed to control the diseases of the crops. Okay, then weeding process. Okay, that grass, extra grass will be removed manually. Then finally it will be harvested, right? Then it will be brought to the home houses, and then it will be separated to get finally the rice, right? So this is a long process, and if you perform manually, then there will be the labor cost will be very high, right? So nowadays whatever you spend for getting the rice and whatever you means like for the labor and then that plantation everything, right? Whatever you get from harvesting the crop, and if you sell on the market, that is not sufficient. Okay, you are not able to save sufficient money to run the family, right? So because of that, the application of the robots are nowadays in use, right? Mostly people are using now tractors in the village areas also. We cannot see nowadays buffaloes and cows using for plowing, right? So now tractors are using, and then they have the full water tanks, so they spread the waters as well as this. They're plowing the field and they're spraying the water so that it will be ready for cultivation. Then automatic means plowing of this means putting of this uh, rice plants, planting of rice plants. Then this is the remote means observation of the fields, like whether there is some kind of diseases has occurred or something like that. So image processing and then drones will be used to investigate or check the field. Okay. Then if you find some kind of diseases on the field, then you can go for the pesticides. Okay, so you can use the robots like drones and some kind of robots for spraying the pesticides. Then weed controls can also be performed by robots. Then harvesting of the crops, directly you can separate the crops by the tractor, okay, or harvester. So likewise the easiness has been developed by using the robots, right? So these are some of the applications of robotics in various fields that I have discussed to you. Right. So I want to show you some videos that will give you some development. Okay, futuristics concept. So I hope all of you have seen this kind of videos in YouTube's, like in Facebook's also some kind of image videos used to come, right? Like they used to give suggestions if you start seeing on the YouTube's. So these are some of the conceptual robots that are developed. Okay, I think this one, this one. So is audio is audible? Audio of the video? Okay. So some lagging is there in the video. So let me show you the direct video. So I think it will be more clear. Yeah, yeah. So I think stop there just to give the idea. So lastly, we can go to this one, this topic, last topic of the today's discussion, consequences of the robots. Like so, as I mentioned, that we have discussed all those applications, then future of the robots. But in the other side of the bad side of the robots, like whenever we use the robots, then like thousands of the workers used to lose their jobs. Okay, so this is the some of the data that is available in the internet. So every robot added per thousand workers in the US, wages declined by 0.42%, and employment to population ratio goes down by 0.2%. Okay, so that is the disadvantage of application of the robots. But in many industries, they are required the production rate high, right? So the industries are now opting for the robots to increase the production and then to increase the accuracy and the quality, right? So because of that, like around 4 lakhs jobs has been means lost by the US population, right? So likewise, this is the bad side of the robots that we can see, right? So we have to work on this. So if I have to mention that like most of the, if we use the robots, okay, in industries, the workers that will lose the jobs is because of this machinist, assembler, material handler, and welder, right? So these are the person who works manually for performing the task. And if you use the robots in industry, this region of the worker, they used to lose the jobs, right? And in by 2025, the uses of robots will be quadruple, that is the 4 times will increase. So there is very big chances of losing so many workers in the industries their jobs, right? So we have to see the both sides of the scenario here right now, right? So in one side we have to increase the productivity because most the industries are very much competitive nowadays to catch the market. So in every 1 minute the production uh, that means updation of the robots means sorry the updation of the products are coming out. Okay, there will be a means modification of the products that is coming out, right? So there is a very big competition in the industries, so they will be very much keen to use the robots to get the work done in a faster way. But other side also, like if you use the robots, the workers who were working for a long period of time, they will lose their jobs, right? So there should be some kind of primitive measures that should be taken care, like the person whatever they are working for a long period of time, they should be trained for like skilled laborers. They have to be improved their level of working so that they can be placed in some other means place where the skilled labor is required apart from the usual repetitive work where the robots can be used. Then replacement of the workers. Okay, so like they have to be transported to some other places where the labor workers or manual workers is required. That has to be done. Okay, likewise we can give the preventive measures for the losing of the jobs from the workers, right? So lastly, just to give the this one, okay, just to, for a few seconds. So this is the development of humanoid robots, intelligent. Okay, from that I'll stop the discussion. So this is a Sophia robot basically. So it have she have the intelligence, artificial intelligence. right? So this is the advancement of the artificial robots that we have now. Okay, so they can take the decision, they can converse, make the conversation. That is a social robot. Basically, the Sophia is the social robots. So she have got the citizenships in UAE also right now, right? So that's all about the robotics. I think I'm not. I have closed the time, so sorry for that. Thank you, Bishop. Yes. Okay.